Hi, so this is the video lecture on the independent samples t-test. So this is the hypothesis test that allows us to compare two group means to each other. So we're going to look at several examples here. For all of them, there's the null hypotheses are going to be the same. The null hypothesis is always going to be mu1 equals mu2. So we've got group 1 and group 2, and the null hypothesis is that the two means are the same. The alternative hypothesis could be that group 1's mean is less than group 2's mean, that group 1's mean is greater than group 2's mean, or that the two means are just different. And in StatCrunch, the way they write the hypotheses, they don't write mu1 equals mu2, they write mu1 minus mu2 equals 0. Or, for example, mu1 less than mu2. Instead of writing it like that, they'll subtract mu2 from both sides and write mu1 minus mu2 is less than 0. So that's what you'll see in StatCrunch. But really it just means the same as those right there. So let's start with an example. In this example, we're going to test the conventional wisdom that it's beneficial to eat breakfast the morning of a big test. So we've got a group of high school students. I'm going to randomly assign them to two groups. By the way, this is an experiment, so if there is a difference in the groups, we can conclude that it's because of the group that they were assigned to. So one of the groups is going to eat breakfast before taking the SAT, and the other group is not going to eat breakfast before taking the SAT. So we've got 25 students in each group, and in the group that didn't eat breakfast, this was their mean and standard deviation, and then these are the results for the other group. And so we want to test at the 0.05 level whether students who eat breakfast score higher than those who don't. So we need to label the groups. And on all these problems, I want you to tell me what's group 1 and group 2. So just to keep it simple, whatever is described first in the problem, we'll call that group 1. So in this problem, we said that the group that didn't eat breakfast came first, so we'll just call that group 1. All right, so the null hypothesis, as always in this section, is going to be mu1 equals mu2. But we have to think about how to set up the alternative hypothesis. In this one, we want to know if people who eat breakfast score higher. So group 2 is the people who ate breakfast. Group 1 was the people who didn't. Therefore, this is going to be less than. So the reason is that we want to know if this second group is bigger than the first group. So that's going to be mu1 less than mu2. So let's go over to StatCrunch, and I'm going to pull these values up here where I can see them. So if we go to StatCrunch, we're going to go to Stat, T-Stats, toSample with summary. So toSample with summary. And our sample mean, let's see what we have. We've got 418 with a standard deviation of 56, and that was based on a sample of size 25. And in the other one, we had a mean of 438 with a sample standard deviation of 49, and that's also based on a sample of size 25. I need to mention here that there's an option here about pooling variances. We're always going to uncheck that box. What that means is that we are not assuming that the two population standard deviations are the same. Don't worry about what that means too much. Just know that we're always going to uncheck that box. Okay, and let's see, for this one we wanted to know if mu1 was less than mu2. I think that's what we said. So we'll click the, we'll pick the less than box. All right, so pick the less than and click compute, and we get our results. And just like we always do, you copy and paste your output into your homework. So this gives us our hypotheses, our test statistic, and p-value. And we still have to state our rejection rule and conclusion. We're going to reject H0 if p-value is less than 0.05. And this is not less than 0.05, so we're going to fail to reject H0 and say that there is not sufficient evidence to conclude that, on average, eating breakfast makes you score higher on a test. Okay? I put a slide here to say that basically there is such a thing as a two-sample z-test, but from here on out we're not going to worry about that. We're just going to go with the t. You can read that. All right, so for a second example, we've got two groups of people who have high cholesterol, and we're randomly assigning some of them to eat oatmeal and some of them to take Lipitor for a period of time. And we want to know, is there a difference in the results from that? And so we want to know, does the mean of the oatmeal, we're going to test the Quaker's claim, which is that eating oatmeal every day for a year lowers your cholesterol more than Lipitor. Okay, so we want to know, are these values greater than these values on average? The oatmeal group, do they have bigger values than the other ones? Because those all represent decreases. So I've typed these data in already. So we're going to stat t-stats to sample with data. Sample 1 is the oatmeal group. Sample 2 is the Lipitor group. We're going to unclick this box. And we think that group 1 is bigger than group 2, so mu1 greater than mu2. Click that and compute. And we get a test statistic of 2.6418 and a p-value of 0.0075. Appears I made a mistake typing in the data when I did it before, so let's just go with what we have here. I'll copy and paste this over here. So our test statistic is this, our p-value is 0.0075. Therefore, we are going to reject H0 and say that there is sufficient evidence to conclude that oatmeal lowers cholesterol more than Lipitor on average. Again, always make sure that you uncheck the box for whether to pool the variances. So we don't want to pool those variances. All right, so the effect size. For looking at the effect size, this is very similar to what it was with the one sample t-test. The only difference is we do the difference in the means, the difference in the two sample means, take the absolute value, and then divide by the larger of the two standard deviations. The guidelines are still 0.2, 0.5, and 0.8. So if we look at the second example, the first example that we had one group had a mean of 418, the other had a mean of 438. So we do 418 minus 438, and then make it positive. So take the absolute value of it, and then divide by the larger of the two standard deviations, 56, because that's bigger than 49. We get 0.3571. Which is in the small to medium range. So we'll say that's a small to moderate effect. let me tell you why we picked the larger of the two. That's because Cohen said it really doesn't matter which one you pick. But in reality, we're going to get two different numbers if we pick whichever one we pick. By picking the larger one of the two, we're getting the smaller effect size, the more conservative effect size. So if we have a choice between two effect sizes, we're going to pick the one that doesn't overstate our results. Okay, so we're going to be cautious in making conclusions here. So that's why we use the larger of the two standard deviations, so that we get the smaller of the two effect sizes. All right, so that's how to do the effect size. Now let's talk about SPSS. So for the same data set we were looking at before with attention span, let's test for whether there's a difference in the mean attention span for males and females. So to run a two-sample t-test in SPSS, we're going to analyze, compare means, independent samples t-test. Now we've got attention span is our test variable, and the gender of the participant is our grouping variable. So gender is, I'm going to exit out of here for just a minute so we can look at the data. Gender here is our variable that we're interested in for grouping. So we've got males and females that are, males represent ones and females are twos. So we need to know that so that when we go to independent samples t-test and we pick our grouping variable as gender, we need to click define groups here. This tells us that group 1 is males and group 2 is females. Okay, usually that'll be ones and twos or sometimes zeros and ones, but you need to look at your data ahead of time and see what that is. And again, we've got attention span for our test variable. So click OK, and that gives us summary statistics for the two groups. It tells us what the attention spans are and the standard deviations and the sample sizes. All right, so here's the results of the independent samples t-test. And I put this over here so we could see it a little better. Now, there's a lot of information on here that you don't need. So let me tell you what you don't need first. This here, this Levene's test for equality of variances, ignore it completely. That is not anything we're ever going to look at. What we're looking at is really two boxes here. We've got, this is the test statistic, and this is the p-value. So we're looking for the t and the sig two-tailed for the equal variances not assumed row. So this is the same thing we looked at in StatCrunch, where you uncheck the box for equal variances assumed. So just like we had before, this is our p-value for a two-tailed test. So if we want to do a test of mu1 not equal mu2, this is our p-value. So let's suppose that's what we did. If we did that, then we'd have, these would be our hypotheses. We've got our test statistic and p-value that came from the SPSS output. There's our rejection rule, and our conclusion would be reject H0. There is sufficient evidence to conclude that the mean attention spans for teenage males and females differ. So because on this one we've got a two-tailed test. And to get the effect size, we look at the descriptive statistics. That was on here. You get the difference in the means, take the absolute value, and then divide by the larger of the two standard deviations. Okay. Now, what if what we wanted to do was a one-tailed test instead? Then what we do is we do just like we did before. we take this sig two-tailed and divide it by 2. And the way you know which way it goes is you look at the data here. This says that in the sample, females have a greater attention span than males. That means that if you're going to do a one-tailed test, the one-tailed test should be testing whether females have a greater attention span than males on average. Okay, so that's why here that's the direction I used. All right, so for that, the alternative hypothesis is less than instead of not equal to. The test statistic is the same, but the p-value is divided by 2. And we'd get the same result. We'd still reject H0, and we'd get the same effect size as what we got over here. All right, so that's it for that section. And, as always, let me know if you have any questions.